Have you ever found yourself scrolling endlessly and endlessly until you find yourself consuming, not creating? There is a massive lie being told to computer science and data science students right now. We are told that if we finish our requirements, pass our exams, wait for the 2026 graduation date, a job will be waiting for us. But the reality is, generalists are already being replaced by AI. If you are a student, you're already falling behind. Over the last 60 days, I completely disappeared from posting. I went radio silent because I realized I needed to stop studying and start building. I challenged myself to build 6 startups in 60 days. Not toy apps, not rappers, real systems. I'm going to show today what I built and how I transitioned from theoretical knowledge to practical knowledge that can be used in real world production environments. So I'm going to start by referring to my GitHub. What I originally planned to build were 8 startups in 60 days. While I only accomplished 2, the first 2, it was a tremendous learning experience for me. So starting off with the first startup, LexRix is an AI analysis tool that scans terms of service and contracts and breaks them down into plain English. I don't know about you, but whenever I sign up for an app on the App Store, I don't take the time to regard reading through the terms of service, taking into the fact that how they may be using my data. So I decided to try and build something that scans text in terms of service and flags any predatory language that may involve the consumer in any way. So it, the front end is built using Python and Streamlit. There's no hosting. Streamlit does all the hosting. The back end is PostgreSQL, and I can go further into that a little later. So I'm just going to show an example of how this works. Hopefully everything goes well. So I scanned deliverables terms and service contract. They're basically a platform that allows non-technical users to build easy and available apps. So when I did scan this, it did bring back a risk of 83 out of 100. Now that is pretty high. It did flag 5 clauses in the terms and service. It is heavily one-sided against the user. The text it analyzed is as followed. You unlovable each waive any right to a jury trial in any legal proceedings arising out of or related to the terms and service. So, in plain English, the clause stripped the user of the right to a jury trial, forcing them to potentially biased arbitration, which limits their legal recourse. The second one, they may terminate your account or access to services for convenience by providing you with advance notice. This allows the company to terminate your account without cause, leaving you without access to services or any recourse. The third one, auto renewal / predatory billing. Except where required by law, all fees are non-refundable. This traps users into paying fees that cannot be refunded, even if they are terminated without cause. The fourth one, post-termination survival. Termination of your account in these terms and your right to access to the services, but does not affect any rights or obligation that by their nature should continue. For example, intellectual property rights, disclaimers, limitations of liability, indemnification, and payment obligation. So in plain English, that is stating this allows certain obligations or right to persist even after termination, which can cause detriment to users. And finally, perpetual licensing. You grant us a non-exclusive worldwide royalty-free license to your name, logo, and trademarks to identify you as a customer on our website. So, plainly speaking, this grants the company extensive rights to your branding without compensation, which can lead to misuse or misreputation. Now, that is very concerning, and I doubt people that use Lovable really understand what they're signing up for when they use these types of products. Now, I did add in here that you can download a PDF, you can share it to social media. Um, Now, I just want to make a disclaimer. LexRix is an AI-powered assistant, not an illegal professional. This analysis is for information purposes only and does not constitute legal advice or an attorney-client relationship. Now, let's break down the second startup that I decided to build. It's called Recall. When you're building your healthcare coordination platform, you can't just ship a fragile prototype. I tried doing that by adding SMS and email routing, but that only led to many compliance delays. When you're dealing with patient scheduling, complex enterprise routing, and strict compliance requirements by telecommunication providers, it can cause many bottlenecks, and if the system goes down, it could affect clinic functionality and affect how their patients may receive treatment, so that is very concerning. So I needed an architecture that allowed me to iterate at the speed of a solo founder, but scale with the security of an enterprise tool. Here is the exact stack that I use. Now starting with the GitHub, it's mainly built with Python, Supabase for the backend, hosting I use Railway, I use Cloudflare for an extra layer of security, and Resend for the email routing. So here is a very terrible illustration of how it looks and how it works, but I hope it serves its purpose. The core orchestration is written entirely in Python. I chose Python because it gave me the raw speed to build out the complex logic, handle the backend transformations, simply and easily without fighting the language. Now it's hosted on Railway. To get it live, I deployed the entire engine on Railway. Now if you are a student still messing around with manual server provisioning, I ask you to stop. Railway give me instant CI/CD, continuous integration, continuous development. I pushed it to GitHub. My environment is automatically built and deployed. It completely eliminated friction so I could focus purely on writing the application logic. For the data layer, I bypassed AWS entirely and went to Supabase because Recall handles sensitive coordination data. I needed a Postgres database with advanced security out of the box, and Supabase was my choice because it gives me row level security, RLS, meaning I can write strict policies ensuring that one clinic's data is mathematically isolated from another's. It handles the database and the authentication in one unified layer. Next is the communication bridge. A coordination tool lives or dies by its ability to actually reach the patient in the clinic reliably. I integrated Resend for the email API because it is incredibly developer focused. The latency is practically zero. It allows me to build complex dynamic email templates right into my Python workflow without ending up in the spam folder. Now, I think one of the most important things for this is adding Cloudflare. You do not put a healthcare tool on the open internet without a shield. The entire platform is routed through Cloudflare. I use it for DNS routing, but more importantly, for their web application firewall. Cloudflare observes any malicious traffic, botnet attempts before they ever touch my rewrite servers or my Supabase database. So this is what the website looks like. Not too complex. Still a work in progress, it's still in beta. I'm working in to get to V1, just tying up some loose ends and rods to make sure that it fully functions as intended. I've also built a privacy policy page, noting how this data may be used and how we collect data, a patient intake form as well. But I'm gonna add what really helped me during this build was using multiple agents at a time. For an orchestrator, I use Kimi K2. For the plumber, I use CatCoder Pro via their VS Code extension. For a QA, I use DeepSeek R1 and sometimes Clostro. For the translator, I use Quen, the 32 billion parameter. The lead engineer for codecs, automation. N8, it's really good for automating agentic workflows. Taking payments, which is Stripe. The Shield is Cloudflare, using Resend for the messenger. Writing most of the boilerplate code is Windsurf to do analyses on the industry that I'm currently building. I use Perplexity, and I did help in the front end using V0. Now, using multiple agents at a time can bring up many different issues, i.e. slop in the code, terribly written code. So to mitigate against this, I did review most of the outputs and isolated them using unit test. But to go a step further, what I'm working on next is how dangerous these models can be. I've recently heard of many stories of many businesses having their code bases entirely deleted from running automated agents, either via OpenClaw, Codex, Claude Code. So it really kind of puts into perspective, if you use these tools without any guardrails, it can make really damaging effects to a business or even a solo developer. So did I hit my goal of 6 startups in 60 days? No, but I did build 2, Lexrix and Recall, and I'm infinitely more proud of that failure, even if I had not succeeded. I learned more in those 2 months than I did studying just for study's sake. I learned as I was going, and it just opened more and more areas of knowledge that I am grateful for. And that ties in with my next startup that I'm going to build, which is called Guardian. While we are deploying massive amounts of AI slop, agentic workflows, multi-agent swarms into production environments, it can cause massive amounts of security vulnerabilities in these systems. I'm currently trying to architect a 2-part security feature. The first layer is Scout. It is a lightweight version of how Claude's internal security works. They had just released a statistical analysis tool, I think about 4 days ago, for only their enterprise clients. While the tool looks very good, what about all the other people who want to use this to see if their code has any vulnerabilities. So it leaves a gap in the market for others to innovate and create something of the same value without gatekeeping its access to enterprise clients only. And that's what Scout is. It's a statistical analysis tool, but built specifically for AI. Before an agent even before an agent is allowed to execute a workflow, Scout is going to audit the output across multiple models, scan for exposed secrets, logic flaws, or malicious formatting, and if there's any malicious intent that the models take, it records a timestamp of that, showing exactly what happened and why. But statistical analysis is only first line of defense. You also need runtime enforcement. This is what Guardian is. For this, I completely dropped high-level languages, went down to bare metal C++ and Rust. Guardian acts as an OS level security sandbox. I'm currently trying to use kernel level eBPF interception to monitor and physically blocked predatory agentic behavior the second it tries to execute. Scout audits the plan. Guardian guards the execution environment. Now this is very easy to say, but very difficult to do. I have no knowledge of kernel level programming, but I do have a desire to build something that will help these businesses. And that is why I'm trying to build Guardian. If anybody from this video watching knows any resources that may help, please reach out in the comments. And this brings me back to entirely why I made this video, and why I completely went silent for 2 months, to just put my head down and start coding. There is a massive paradigm shift happening right now. The barrier to entry for writing code has collapsed, but the barrier to engineering simple, secure systems has never been higher. If you are sitting in a lecture right now, waiting for a piece of paper to tell you that you're ready to enter the industry, you may be left behind. That's what I feel. Do not wait for permission. Do not wait until you understand every layer of the stack. Pick a problem that is big enough for you, open your IDE tonight, and just start building. Whether that may be Vim, VS Code, or any other of the IDEs out there, just get and start building. I'll be documenting the entire architecture of Scout and Guardian, including the C++ level code over on my Substack and X. I'm going to put the links in the description. It has never been a more paramount time to stop consuming and start creating. I'll see you in the next one.